It doesn't like you.
There we go.
Okay. So when I first moved to the Chicago area about 6 or so years ago, I realized that I didn't really know what was in our tap water and didn't really know what kind of plants were going to work well with whatever was in our tap water. And I realized I didn't actually know that much about fertilization either. So as I set up some new aquariums, I took the time to really thoroughly understand basic concepts around water chemistry with a goal to better understand and control my water chemistry to grow better plants. There's a ton of expertise in this room. So as I go through, if something strikes your mind as a comment, or you disagree perhaps with something that I say, or please feel free to comment, ask questions, and discuss. Oh, one more thing. Every picture that you see in this presentation are photographs of my tanks. I do actually make my own macro fertilization. And through our COVID times, I think the houseplant craze, I caught it too. And I do have probably 150 plants in my house, which are all well, not all of them, but most of them semi-hydroponic setups, and I make my own fertilizer macros for that as well. All right, so objectives today are to, and the majority of our discussion will be around understanding what plants and fish want in their water. And then at the end of the presentation, we'll do a little bit on how to find and interpret your water chemistry report, set targets for your water parameters, use additives to achieve those parameters, and then also talk a little bit about troubleshooting CO2. So what do plants need in their water anyway? Well, it's nutrients, right? So we can think of that in 4 different categories. Non-mineral elements, hydrogen, oxygen, and carbon, which they're getting from water, dissolved oxygen, and dissolved CO2. Major macronutrients, that's your NPK or your macro fertilizer, which you can get from, again, adding macro fertilizer, fish mulch, and decomposing plant material. Minor macronutrients, so that's calcium, magnesium, and sulfur, which is already in our tap water, but how much? And it does vary by geographical location. And then what we call our micros or micronutrients, mostly boron, zinc, manganese, iron, copper, molybdenum, chlorine, and other trace elements. And that's your micro or your trace fertilizer. So what are the key factors that influence the availability of those nutrients to plants? So some of the concepts and ideas that we'll talk through here are nutrient ratios, right? How much of one nutrient as opposed to another. We'll talk about the ionic form that nutrients may be in to make them less or more available to your plants. We'll talk about pH, which again influences nutrient availability, and we'll talk about KH. So ratios are important. And what you see here is a whole lot of confusing. And I'm not going to go through all of these antagonism, stimulation, types of relationships, but the take-home point here is too much of one nutrient can actually limit the plant uptake of another. Not sure what that is. Can I just close it? No, close tab. Okay. So when you see something that looks like a deficiency, you actually might not have a deficiency after all. You might actually have an overabundance or an excess of another nutrient that's competing, and as much as a lack of a presence of another. Now, the ionic form of nutrients is also influencing that competition between the elements. So nutrients don't generally exist as stable molecules, right? They're dissolved in a solution, right? So they exist as ions, and plants can uptake either positively charged cations or negatively charged anions. And again, when you put ionically bonded compounds in water, you get an aqueous solution, and then they separate into the anions and cations. So just using potassium nitrate, which is actually it's the main nitrogen source that I use in my fertilizer, KNO3, which is a solid, plus H2O, which is a liquid, in solution gives you K plus aqueous and NO minus aqueous, right? So the K plus and NO minus in an aqueous solution of water. So plant nutrients can be available in different forms. So what I'd like you to look at here is you can see going across the rows, these are the same nutrients, but you can see they're available in different forms, cations versus anions. So nitrogen can be available as a, I don't know what 4 plus is, as a cation, right? What's that? No, it is ammonia, but it's not trivalent. Is it quadvalent? Anyway, so I think it's a quadvalent cation because it's 4 plus. It's right. Whereas it can also be available in the form of NO3 minus, right, which is a trivalent anion, right, and the ability. And you can see the same for potassium, right? Different forms of, potassium being positive, phosphorus being negative, right? It can, and able to have, different valencies, right, in terms of how negatively charged it is. Calcium being positive, which is a 2 plus. Magnesium being very similar, right, in having that being a divalent cation, sulfur being a divalent anion, et cetera, et cetera. The very best prepared fertilizers that you will buy or that you can buy generally have nitrogen available as both ammonium, the cation, and as nitrate, the anion, because that gives the plant some flexibility, right, to be able to actively absorb the nitrogen in both a situation where it is has a more positive charge within the root zone versus having a more negative charge within the root zone. And I'll get into more details with that in the next slide. So plant cells need to have a slightly negative charge in their inside. So if more cations with a positive charge than anions are present, an increase or decrease in cation uptake occurs to restore those physiological conditions for the plant to continue to have that slightly negative charge in their interior. So how do plants get nutrients into them? Well, there's passive transport where the ions, just with a regular uptake of water into the plant, are just going to be absorbed into the plant by osmosis, right, without any energy from the plant. And that can be affected by a number of things: temperature, photosynthesis rates, all kinds of stuff. Active transport requires energy from the plant. And this is affected by competition between ions based on their individual charge. So I was talking a little bit about the monovalent, the valency, right? Is it monovalent, bivalent, trivalent, the quadvalent, which I couldn't figure out how to describe. But those monovalent single charge ions are actually moved more easily into the plant than divalent ions, those double charged ones, which are moved more easily than the trivalent, which would be moved more easily than the quadvalent, right? So the more charged the particle is, the more difficulty the plant has uptaking. So what does that mean? That means that a plant would accumulate more potassium, which is a monovalent, or more easily accumulate potassium, a monovalent ion, than it would calcium and magnesium, which is a divalent ion, due to their difference. Okay, so here's sort of an example of that. So here are the two different ionic forms of nitrogen, right? Nitrate and ammonium. Now, if we start with the plant on the left, an excess of nitrate increases the uptake of potassium, calcium, and magnesium, right? Because the excessively negative charge within the plant can increase the cation uptake or alternatively decrease the anion uptake. If we had an excess of ammonium cations, that would actually decrease the uptake of those other positively charged cations like potassium, calcium, and magnesium, because an excessively positive charge in the plant is decreasing that cation uptake or increasing the anion uptake. So this is an example of trying to show why the very best fertilizer, prepared fertilizers that you buy generally have both nitrate and ammonium as their nitrogen source, because nitrogen is the #1 most important abundant macro fertilizer that your plants need, and having the both cationic and anionic form allows the plant to be able to uptake it regardless of the other nutrients that it's been absorbing. All right, so let's talk about pH. pH is actually the power of hydrogen, right? So it's a measurement of the concentration of hydrogen ions in water. So a low pH means that there are more hydrogen ions in the liquid, where a high pH means there are very few hydrogen ions in the liquid. And remember, this is a logarithmic scale. So one step difference in the amount in the pH measurement is actually a significant difference in terms of the quantity of hydrogen. And why is pH important? It impacts the behavior of chemicals. So it controls the availability of nutrients, biological functions, and also microbial activity. So here's an example of another important nutrient, phosphate, right? So depending upon the pH, phosphate actually is going to change forms and be different in terms of its ease of absorption for the plant, right? So when it's trivalent, again, that's the 3-, it is not particularly easy for the plant to absorb. As the pH increases, it becomes divalent, again, a little bit easier. Monovalent, the easiest, and then phosphoric acid when the pH goes, actually, I apologize. I think this is actually the pH going down, but phosphoric acid, where that is not actually available to the plant, and because it's not an ion. And at that point, everything would be dead in your tank anyway. So you're not very likely to have phosphate in your tank in the form of phosphoric acid, but you can see how the pH does actually influence the availability of phosphate for your plants. Okay, so more on, right, okay, and here I've actually put the pH values in, right? So you can see the pH is going down. When you put phosphate in water, the anions coexist according to dissociation and recombination, right? So you're getting these, so at like pH of sort of 4 points in this sort of 4.7, this and even lower range, it's becoming more available to plants. And here you can see like the charts of the three of the different forms where depending on what pH. So if you're at pH of 6, let's say, which actually a lot of my tanks are at a pH of around 6, you're going to have a mix of mostly H2PO, what does that say? H2PO4 minus, there we go, H2PO4 minus. But you will also have a little bit of the H2PO4 minus. With phosphate, ideally, you would actually want the pH to be really, really low. However, other nutrients are not going to be as available as phosphate would be. Because of the nutrient availability varies, right, with with pH, right? And so here you can see, looking again, starting with nitrogen, phosphorus, potassium, which are our 3 NPK, right? And then our other important nutrients, calcium, sulfur, calcium, magnesium, right? These are actually in order of the amount of nutrients that is important for the plant to have. And you can kind of see the areas that are like the bright green are where they're most available. And so with the sweet spot here is in this area between 5 and 7.5, with somewhere around 6.3, let's say, being where you have most of these nutrients being relatively easily uptaken by the plant. What about fish? Because most of us, some of us, have fish in our aquariums as well. Michael's laughing because he's been to my house and knows I have several tanks with no fish in them. So pH naturally varies throughout the day in natural aquatic environments. And the pH range that fish are comfortable in really varies between 4.5 to 9. And just like plants, most fish are pretty happy from 5 to 7.5. All right, the controversial KH, Kalkwasser hardness. So let me start by saying that I use RO water in all of my tanks, and I remineralize with calcium and magnesium, and I do not add anything to add KH to my water. So my KH is effectively pretty close to 0 in most of my tanks. Now, some people would be very shocked by that, but I've never had a problem. And here's why. So KH is a measure of carbonate hardness, right? Or the presence of carbonate and bicarbonate anions. So water that's flowed through limestone, which we have a lot in America, tends to be high in both calcium and in carbonates. And these carbonates increase pH, and they also act as a buffer to resist swings in pH. And that's why it might be a little bit controversial for me to have 0 KH in my tanks, because presumably I shouldn't have a buffer, and any acid, tiny bit of acid that you add to the tank or any tiny bit of base that you add to the tank could cause a drastic swing in the pH if there's no buffer. But carbonates provide little value to plants, except in the case of biogenic decalcification, which I'll get into in a later slide. Fluctuating KH impacts the osmolarity of the fish, or their ability to keep all of their salts, within their body. And one of the fish can handle big changes in pH. They can't handle big changes in KH. So if you are doing something like using RO water, make sure that, and you are adjusting the carbonate hardness of the water, make sure you're doing that before you add the water to the tank and not while your fish are in there, because it could it could cause some problems. One of the things with having low KH, and this is something that I observe in my tanks, that snail shells don't do very well, right? So I don't usually have snail problems because they have, very, I still have snails, actually. They just don't tend to do very well because they need that carbonate and to build their shells. And competition between carbonate and other anions for active plant transport mechanisms, again, reducing the availability of nutrients for the plants. And general rule is all plants, actually this isn't true, and I'll give you an example, but all plants, almost all plants do well at low KH, but some actually require it. So if you think of things like tonina, eriocalions, amannia, these are plants that if you put them in our tap water that comes just straight out of the tap, they don't do so hot. The one exception plant that actually really does like high KH is Vallisneria. American, that's true, American Vallisneria. It doesn't do very well in my tanks, and I think it's that KH issue specifically for it. No. Any of which? Oh, no, those ones I do. Yeah, absolutely. Because my KH is 0, right? And that's Tonina's sweet spot. But Java fern, you guys have seen my Java fern, right? That I've donated, that's like this big and amazing and healthy, right? So even though it can tolerate a very high KH, it does not need a very high KH. And I don't know, do you guys know any other examples of plants? I can only think of the Vallisneria americana as being the one that actually likes high KH water. Do you know of any other examples? Hornwort, yeah. I think there are forms of and it's a pest plant, so a lot of us don't have that in our tanks either. But Elodea, I think also is one that tends to do better at high KH. Pogostum helferi, yeah, high KH, yeah. That's my next slide. So the KH exception, right, is biogenic to calcification, right? So some plants can actually use carbonates as a carbon source and will grow better in high KH water when deprived of other carbon sources. So this is normally seen in high light conditions. And actually, I saw it in my tank when I was very first setting up before I had gotten an RO system when I was still using tap water. And I saw it on Vallisneria and Elodea. It's very energy intensive for plants to do this. So they only do this when they don't have enough carbon, right? Sources, generally that's CO2. So in non-CO2 injected tanks, this is something that you may see if you're putting really bright lights on plants that are able to do this. And some of those plants are the Elodea, Anacharis, Anubias, Cryptocorynes, Vallisneria, and Sagittaria. And they tend to be very easy, hardy plants that do it. And you can tell if that's happening. You can actually see it happening in your on your plants, because this calcium, you'll get to see form these calcium deposits on the leaves. It's really very interesting. Okay, so here's the controversial question. Don't I need to have high KH to resist pH swings, right? And I'll get into like a little bit of detail on buffers and how high KH is working to resist swings in pH. But I'll give you a preview of the answer, right? So the acid neutralizing capacity of any solution, right, is equal to proton acceptors minus proton donors, right? So it's giving or taking these proteins or protons. So a buffer is a combination of a weak acid and its conjugate base, and of course carbonate and atmospheric CO2 form a buffer in solution to resist pH changes. And what does that mean? Okay, so atmospheric or injected, if you have a CO2 injected tank, dissolves in water to form a weak acid, right? So, and that acid is H2CO3. As you can see from the formula there, it's dissolving in water, which is a weak acid. Adding carbonate into the, and you'll have this if you have CO2 injection, you'll have this if you don't, because we have CO2 in our atmosphere. So when you add carbonate to the water, that carbonate, it gives you calcium plus HCO3 minus plus OH minus. And HCO3 minus is the conjugate base of H2CO3, right? You can see one is H2CO3, one is HCO3 minus, right? We have a, so in a test tube, if you were to add calcium carbonate to a test tube, it acts as an effective buffer, right? You can put a ton of acid in that test tube without measuring a change in pH. Without it, you add a couple drops of acid and you'll have a dramatic reduction in pH, right? And that's the argument. This high KH helps you to resist pH swings, right? But in an aquarium, you have lots of different proton acceptors and proton donors, not just in the water column, but also in the, in the organisms, plants and fish that you have in the tank, and especially in the substrate that you have in the tank. And if you have soil like aqua soil in the tank, then soil is probably one of the best proton donors and acceptors that you will find around. So soils have a cation exchange capacity. So, and aqua soil acts as a buffer in and of itself because it has a high cation exchange capacity. And here you can see some common substrates on the left, play sand, gravel, fluorite, EcoComplete, and then aqua soils, right? And the cation exchange capacity of each is sort of listed there. And a little picture of what's going on, right? At different pHs on a particle of soil is below that, right? So here, when you can see at pH, in the first image, at pH 3.5, that's very low. Your fish are not going to like that. Please don't keep your aquarium at that pH, but it's a good example, right? You can see that the water is acidic, and you have these different soil components, right? A mix of negative and I can't actually tell what that is. I think I need my reading glasses. But here you can see at different pHs, right? There's a different mix of cations and anions that are being attracted to the soil surface because of the pH. So it's really exchanging the ions that are bound to it depending upon the pH, right? Which is in essence buffering buffering the water. Okay, right. And then my very last comment. So yes, I don't bother adding carbonate to my tanks. However, all plants grow well at low DKH, right? And having a KH of 1 to 2, right, isn't a bad idea, right? Because it doesn't hurt your plants, and it's going to give you that confidence of having a buffer. I don't think you need it, right? But if you've had some, I don't know, some horrible catastrophe of something happen that caused a lot of base or a lot of acid to be generated in your tank, maybe you would want that extra buffer of having a little bit of KH in your tank. So I think as a recommendation, aiming for something low, 1 to 2 DKH is probably a pretty good idea. All right, some last notes on aqua soil. So in addition to acting as a buffer in our tank, it actually absorbs phosphate and carbonate, right? So if you have fresh aquasoil. If you've ever done this and actually tested for phosphates in your water column, you'll find that you can be dumping phosphate into that tank and then measure the next day and it's like gone. You're like, where did it go? Did the plants eat it? No, your aquasoil did, right? Also you'll find that aquasoil will make your tank more acidic, right? Again, absorbing carbonate and also releasing humic and fulvic acids. Those are amazing acids. And I mentioned my semi-hydroponic houseplants previously. I add humic and fulvic acids as a pH adjuster to my nutrient solution because they're chelators, right? That increase nutrient uptake in plants, and they'll actually even serve a double purpose of making your water slightly acidic into an area that, into a range that plants really like. So implications: makes water more acidic, and new setups seem to do better with extra phosphate. All right, the other important water characteristic to understand is GH, or general hardness. Now, GH and KH are super confusing because both of them are measured in the concentration of calcium carbonate. What? Why are you taking, one that is actually a measure of calcium carbonate and another that is not at all related to calcium carbonate and, measuring it in terms of what it would be in terms of calcium carbonate? It's very, very confusing, but it has to do with chemistry and how people were trying to measure these things for like more than 100 years ago. So don't get confused. GH is simply how much calcium and magnesium do you have in the water, right? And calcium and magnesium are essential nutrients and they're divalent, so they take much more energy for plant uptake. And more calcium and magnesium needs to be in the water than is taken up by the plant, right? And remember, we've got passive transport, which is influenced by the concentration in the solution, right, versus what's inside the plant. And then active transport, which is influenced by those competing cations. So what's the implication here? Calcium and magnesium are not substantially depleted from the water column by plants, meaning you don't need to keep adding calcium and magnesium to your tank unless you do a water change. However, you do need to add it and make sure that calcium and magnesium are present in the water at fairly high levels, like relative to other nutrients. And in terms of fish don't really care. They're most do well at 3 degrees of general hardness or higher. All right, so where is our recap? So this was the first objective in understanding, what do plants need and why, right? So plants need nutrients, the non-mineral, right? Carbon, etc. Macronutrients and micronutrients. The ratios and the ionic form of the nutrients are important, right? Due to nutrients competing. pH above 7.5 or below 5 is going to decrease your nutrient availability. So that's your sweet spot between 5 and 7.5. Carbonates can decrease nutrient availability. And GH is a measure of calcium and magnesium, both of which are essential, right, to have in a relatively reasonable quantity within your aquarium. Right, so what are good ranges to target, right? Well, the answer is it depends. And there's no one answer, right? It depends on what is the pH of your water, right? What is the KH of your water, what kind of plants do you have, what nutrients do you have in the soil, right? So here are some general ranges and guidelines. Estimative index is a fertilization methodology that some of you may have heard of. I'm not going to go into the details on it, but that is one where you are essentially giving all of the nutrients that the plants might need in excess And the idea is that the plants will uptake what they need to uptake, and you do really big water changes to, make sure that things don't build up too much in your tank. Sort of a rich, type of level of fertilization would be about 10, 1, 12, and with calcium and magnesium, sorry, I'll go, and then lean is more like 5, 0.75, 6. Now, in my tanks, actually, I dose even more lean than that. So I'm targeting 1.5 ppm of nitrogen, 0.7 ppm of phosphate, and about 4 ppm of potassium. But I do have aqua soil, and I do use complete macro and micro root taps. So some ranges to target. So there's some examples of NPK, calcium and magnesium. For calcium and magnesium, generally you want a ratio of anywhere between 6 to 1 to 2 to 1. More magnesium actually seems to be better, particularly at lower pHs. I mentioned my tanks are, around 6. And I actually do use 2 to 1 calcium to magnesium. I use actually this lean recipe of 24 ppm of calcium to 12 ppm of magnesium, and which seems pretty good. You might say, hey, Michelle, why didn't you talk about sulfur and sulfate? You said along with carbon and oxygen, sulfur was a major important nutrient. Well, actually, we don't really have to worry about it because there's so much sulfur in our aquariums. There's so much sulfur in your tap water. Any of the, or many of the salts that you may be adding, if you're like me making your own fertilizer, are sulfate salts, right? So, and plants are not sensitive to having too much of it unless it's ridiculous. So it's generally available in excess and something that you don't really need to worry about. Right, so here's sort of where I'm at, which is, so here are 3 different, methodologies or branded fertilizers that you could buy. So EI is estimated index. So that's not something you can buy, but you can buy salts and dose to those ranges, which are established. Again, that was the first line from the previous. APT Complete, which is the 2-hour Aquarist. This is excellent fertilizer, by the way. You can see that it's targeting nitrates of around 6, phosphates of 2.8. These are all ppm, and potassium of 16. ADA fertilizer, which is a lot leaner, and very interesting too. You can see very high potassium in ADA fertilizer relative to nitrates and phosphates, and you can also see a big range in terms of iron. Also, many fertilizers have magnesium in them. Remember, your water that's coming from your tap has quite a lot of calcium and magnesium in it, and we talked about those ratios, if you remember. So sort of 6 to 1 all the way to 2 to 1. That's calcium to magnesium. The water in most people's, I mean, again, it depends on where you live, obviously, right? But in a lot of areas, you have significantly more calcium than you have magnesium, which is why you see additional magnesium as an ingredient in all-in-one fertilizers. They very rarely have calcium added to it, but often will have magnesium to kind of tip that ratio more in that 6 to 1 to 2 to 1 range. Okay, what is in my water? All right, this is a water report for the city of Chicago. I don't actually live in the city of Chicago. My wonderful water area doesn't actually give a readable water analysis, which is really unfortunate. But let's go through this water report. You can see the important things that I've highlighted. That's yellow, right? Or the important to me. Right? So what's the pH here? Well, it's 7.8 to 7.9. Oh, what did we say we wanted the pH to be for our aquariums? We said 5 to 7.5 at the high end. That's not so great. Okay. But then we're using aqua soil, which does, acidify your water a little bit. So, maybe you're getting down into that 7.5 range regularly. Alkalinity, right? This is also confusing because that's not alkalinity. It's actually the KH. You can see that CaCO3 milligrams per mil, right? So that is 108 to 118 ppms of CaCO3. That is 6.5 degrees of hardness, right? That is very hard water, which is also why I've got it in red here. Okay, hardness in terms of general hardness, 8 degrees of general hardness. That's pretty hard. And what do you have? You have 35 to 36 parts per million of calcium and about 12 to 13 parts per million of magnesium. So the ratio is not too bad, right? In terms of potassium, there's 1 part per million of potassium. Wait, what? That's one of our macros. And here it is in the water column already available at 1 ppm. Ammonia nitrite and nitrate less than 0.1 ppm. That's pretty okay. Oh, wait a minute. How about another one of our major macros, right? Phosphate. You've got 1.2 to 1.4 ppms of phosphate in the water. Remember what our targets for phosphate were. For my tank, I'm targeting, below 1, right? So that's something I think to be aware of if you live in Chicago and this is your water water analysis, is that you actually do have a fairly large amount of phosphate in the water already. Yeah, and Raw Lake looks pretty similar if you look at it, right? pH is higher, but the other parameters are really, really pretty similar. Okay, so what are the implications, right? So that high pH means decreased nutrient availability. So using methods to naturally decrease the pH, like adding aqua soil, some wood can actually leach some tannins and humic acids. Those are really beneficial. Botanicals, right? We were talking about botanicals earlier, Beth. Can also release natural humic acids and things into your tank. So naturally decreasing pH may help short term. I wouldn't recommend doing anything like adding pH up, no, other way, pH down, or other things to try to decrease your pH, but it's something to be aware of and monitor. 6.5 degrees of hardness in terms of KH means that soft water plants are going to stunt, right? So things like the Tanina, and, those other plants that cannot tolerate that high DKH is going to limit your plant selection. And so for more sensitive plants, you may want to consider reverse osmosis water, either using complete RO or mixing RO with tap water, because there will be nothing in your reverse osmosis water. And so if you do a 1-to-1, you'll end up with three and a bit, which is a much more acceptable level of KH hardness. And also that high level of phosphate in the water means you might want to select the fertilizer lower in phosphate, or maybe use a phosphate remover. Okay, so I mentioned that I do make my own fertilizer. I don't make my own microbes. I either use Seachem Flourish, which has only trace elements in it. It's pretty good. Or I use actually prepared from a hobbyist here in the US, Joe, which is Burr Aqua, right? Sells like a pre-made fertilizer mix. You can also go and use other, what is it called? I'm having a blank. Yeah, buying it from Nylock and getting the, what is it called? The CSM. Yeah, yeah. That one's not my favorite. I actually prefer to use Trace or Joe Harvey's mix. Joe Harvey's mix is great. I've been using it for years. But here's the stuff that I have in my chemistry cupboard, right? So KNO3 for nitrate and a bit of potassium. K2SO4 is for additional potassium, and of course it's got sulfate. KH2PO4 for phosphate, CaSO4 for calcium, MgSO4 for magnesium, and KHCO3 for carbonate. I do have that. I don't use it, but I could, and I probably should, but I'm lazy. And you can use, there are tons of nutrient calculators out there, but this one, rotellabutterfly.com, it's really, really easy to use to figure out how much of what you want to be putting in your tank to achieve certain targets. And one of the things that I do actually in making my fertilizers too is I leverage the great work of companies and other individuals. So if you look at the back of your fertilizer, they have to tell you the amount of NP and K that is in the fertilizer that you have. So you can without too much difficulty, figure out the parts per million of each of the fertilizer components that you're putting into your tank when you're dosing according to their directions. And then you can back calculate, right? Using something like Rotella Butterfly, how, if I was going to make a solution that would be similar, even if it's in a different sized container, how much KNO3, K2SO4, and KH2PO4 do I need to put into that container to mix up a solution that I can then stick in my autodoser or use to dose my tanks. Okay, the very last subject is CO2 optimization, right? CO2 is the main carbon source for your plants, and it is a major nutrient for them. And so with your CO2, you are in essence looking to target a 1-point pH drop to achieve approximately 20 parts per million of CO2 in your tank. And here you can see one Sunday, I had a lot of time on my hands because you can see all those little dots are individual measurements. I know. So here you can see like first thing in the morning, I woke up, it was really early, 4:48 a.m. and measured the bubbles per second, right, coming out of my CO2 meter, right? And that's really when my CO2 is turning on, right? Is apparently at it's probably at 450, right? That's 448 line is a weird time, right? So CO2 goes on, it's, what is that, 4.5, bubbles per second. Don't go by bubbles per second, guys. It's going to be different for every single tank, for every single setup, for everything. It's terrible measurement. If you really, really, really want to know exactly how much CO2 is going into your tank, at a flow meter. They're a pain in the butt, and you can only buy them from Dwyer directly. It's, but it will tell you exactly how much gas is flowing into your tank. And unless you have something like that, you don't actually know. EPS doesn't mean anything, but it is a good way of knowing if you are putting more in or putting less in, right? Right, and so here you can see the red or orange line going up, that's my CO2 going on. All of this up and down with the BPS is just, it's really hard to measure bubbles per second, right? You know, I'm not counting just for 1 second, I'm counting for 10 seconds and then doing some math. And if you are off by counting 1, that's why you're seeing this fluctuation. And you can see my pH going from 6.9, right, which it was at 5 a.m. down to almost 5.9 by you know, by what time is that, like 9ish, right? So it is taking a little bit, right, for the pH to drop in my tank, but you can see that by the time my lights go on, so that's what those green lines are, right, showing the par, right, as my tank was ramping up in terms of the light, and then you know, ramping back down again. What's also interesting is that in terms of this pH, you can see as I'm hitting that 88 par in my tank, you can actually see the pH start to creep up just a little bit. And that is the photosynthesis in the plants using the CO2 in the tank. But this is something that you want to see, right, is before your lights go on, hitting that 1 point pH drop, and then really that sort of rebound back overnight, and ensuring that you have that sustained 1 point pH drop throughout the photosynthetic period for your plants. So your plants are going to, during the day or while they're photosynthesizing, and of course my tank is getting some ambient light, right, from windows and stuff like that. But while the plants are photosynthesizing, they are going to be absorbing CO2 as a carbon source, and releasing oxygen, right, for your fish. But at night, while your plants are sleeping, they're actually doing the opposite, right? So they are putting CO2 back into the water, right? So that's also, when you're thinking about optimizing CO2, you know, making sure that you have enough circulation in the tank, as well as if you drop so fish can survive more than a 1 point pH drop, but what can happen is they're fine for the first day, and then the next day they're all dead because you're not getting enough off-gassing of the CO2 in the tank, right? So you want to see this curve going really back up to a relatively lower level, so that you don't have over 2 days of accumulation. So that's kind of when you're just first setting up with CO2. But ideally, you want to get to this 1 point pH drop. This is an area fish can survive, and you're really making sure that you're giving that nutrient maximally to your fish. If you were to use something like EI method, for example, that a fertilization where you're putting lots and lots and lots of fertilizer into your tank, and you don't have CO2 optimized so that your plants can actually use more nutrients, you often will end up with problems with algae. So a lot of people will just, yeah, put some CO2 in my tank, right? And maybe you're getting a 0.3 or a 0.2 pH drop. If you're having algae problems, looking at how much you're injecting in terms of CO2, I think can often help solve those problems by making sure that your plants are, you know, getting that good source of carbon. And that's me, I'm done. Thank you guys for listening to me. Comments, questions? Do you know, I used to be a crazy tester, right? I had the Salifert, it makes really, really nice test kits. I was testing for calcium. I was testing for everything under the sun. I bought different pH probes. I can't tell you the last time I tested my pH. Like I don't even know, right? Do I occasionally um, do I, when I change something, right? I will test it, but I just know, right? Because I'm using reverse osmosis water. All my tanks have aqua soil. The yeah, it just is so consistently getting to the same pH. I don't really test it anymore. Probably I should, right? Every now and then, because things can happen in your tank. I mean, I think if you when you're first setting up a tank, right, and when something's new, yeah, test it. It's probably good to test, like every 6 months, every 3 months, maybe, just to make sure that things are, still ongoing. Like I can tell you, like when I mix up hydroponic solution, right, for fulvic and humic acids, I use a like a I forget the brand, but a hydroponics additive called Diamond Nectar, and I know that that is actually pH adjusting because I, measured the pH before, right? But every now and again, I'm like, make sure that Diamond Nectar's been now sitting in my cupboard for 6 months. Like, let's just make sure, right? And then, sure enough, I get reassured. Yep, pH is still, where I want it to be. So, yeah. Well, I do water changes really 50% once a week. Um, it's I do miss some weeks. Um, and I have actually recently downgraded. Like I got rid of one of my 10 gallons, so now I only have 5 tanks. So yeah, but once a week is really to maintain something that looks like this. It's once a week. Well, and when you're switching fertilizers or changing dramatically the types of plants that you have in your tank, right? So this tank has a lot of stem plants in it. If I were to switch that and go, okay, you know what, this is too much maintenance. I'm going to switch more to like Nubius and, even more Java fern and more, Booth and, much more slower growing plants. You're going to want to adjust your nutrients, right? So when I was setting up my tank, I was measuring nitrates, phosphate, potassium, right? To understand and see. And with new aqua soil, I can tell you, you can dose NPK and then come back 2 hours later and test for phosphate, and it's nothing, right? And you can actually see that. And same with nitrogen, right? In this tank, and I was daily dosing, I would dose in the morning and then test for nitrogen in the evening, and I would be gone, 0. And I was putting in like 6 parts per million, which is like not a ton, but it's a lot, right? So it can also tell you if you're in a zone of fertilization that is sustaining, right? If you're every day putting in, I don't know, 10 parts per million of nitrogen, and it's, by the end of the week, you're getting readings of 60 parts per million of nitrogen, your fish are going to be pretty darn unhappy. Yeah, you will start to see, and it's interesting because it depends on what kind of plants you have, right? Some plants are really hardy, like the Java fern. You'll see nothing going on with the Java fern, right? I mean, when it's really happy, it's growing like crazy, right? But if it's not happy, it's still growing, right? It's a pretty hardy plant. Meanwhile, something like rotalas, if you have high nitrate, all of a sudden they're starting to twist and turn, and you're like, what is going on with that plant? And it's because your nitrates are too high. If your nitrates are really low, you're like, wow, my rotalas are gorgeous. They're bright red. They're beautiful. Maybe I need to add more nitrate into this thing, right? So there are some indicator plants that you can use. I think, there is value in testing, right? particularly in newer setups, right? As and as you're changing things in the tank, like swapping out kinds of plants. They expire. Yeah, the test solutions do expire.
Yeah, they do. Yeah, I wouldn't go a year.
Yeah, they
So it's
from.
from.
I said, I switched my other four. And it's not that. Because, and then every color is.
Yeah. pH growth.
Well, you know, you talk about testing and measuring things, right? But after a while, once you've been doing, you know, the same thing every single week, you kind of get, you know, an idea of it. And I think Eloy and I were talking about this, right? So when I do my 50% water change, believe it or not, I'm actually using buckets to put the water back in. I got to fix that. But anyway, you know, I know how many 5-gallon buckets I just used to fill up this tank, right? So then I know how many whatever spoons of calcium, spoons of magnesium I'm tossing into my tank. So I'm not actually measuring that anymore, but I know that with my little scale measuring spoon, right? Like a big plump, you know, spoon of gypsum, basically the CaSO4, is about the right amount per bucket of water, and 2 spoons of Epsom salt, because it doesn't stick on the spoon quite as well, is about the amount of you know, magnesium that I want. And so I'm just like, right, and that's pretty fast. If I had to go and measure out, and I used to, you know, go and, you know, with a scale and measure out the amount of Epsom salt and measure out the amount of gypsum that I'm putting in to remineralize my water with calcium and magnesium. I mean, it's not that bad, but it's like an extra 10 minutes versus standing there going, boom, boom, boom. Because we know that calcium and magnesium are needing to be in the water in excess. We know that the ratio should be somewhere between 2-to-1 to 6-to-1. Do I need to really sit there and spend that, you know, 10 minutes measuring? Probably not.
Just real quick, the Zooks here now, that tank at Overseas is looking great. They're still eating frankly okay. And they're doing water changes like all the time. That's the thing. And in some ways, I said this to Scott, some other people, I said, in some ways, freshwater tanks are now a lot more needy or more nitpicky than saltwater. Before you had to be a wizard and have a point and a half. Now, you know, you can just set it up with this kind of a tank. It takes work, but the average show. But you've got to keep an eye on it.
Yeah.
I mean, I'm the kind of nerd who goes around with my meters. I'm checking on it. pH nothing is 8, 6, 7 something.
Yeah.
This is pretty tough.
pH of 8, yeah. Yeah. Yeah, and you're getting it down to 6, 8, or 7, right? That's within that 5 to 7.5 range. So your plants are going to be fine. Yeah. Yeah.
Yeah, I got them just as they were going because the tank falls so quickly.
Yeah.
But the pH was 7.3, but it's just, yeah, but that's how you follow it. Like a lot of things dying.
Mm-hmm.
Especially mollusks.
Yeah. Any other questions, comments? Yeah. Do you know what I do? When I do water changes, I am really thorough in removing mulm. I know there are different methodologies for it, to our aquarist and others. advocate using a baster and kind of like a turkey baster, right? And poofing the bottom, right, as you siphon up. This is basically a Dutch plant tank. And in this tank, I actually rip the plants out. And then I use actually a gravel cleaner, like an aquarium gravel cleaner for gravel. And I actually siphon my aqua soil like it were gravel, right? And now, then I also do trim my plants, put them back in. And I don't do the whole entire bottom of the tank every week. That's just too much. Besides ripping out all of the plants and putting them back in is like a day's job. So basically one day I'll be like, okay, I am going to, rip out this mint early here and retrim it and siphon that corner, or and then put it back in, and do that as part of my water change. But I think that's important. I also think that renewing your aqua soil, and remember, for a lot of us, our aqua soil is acting to help acidify our water, and your old aqua soil is not going to be as good at doing that anymore. Aqua soil also has ammonium in it, right? We talked about having the different sources of nitrogen. So my mix that I have doesn't have ammonium in it. It has nitrate in it. So the plants are, by putting a little bit, when I clean my tank, almost every time I throw at least a couple of handfuls of fresh aqua soil in, and everything seems to do a lot better. I think partly because of that ammonium, partly because of the buffering capacity of the soil, partly because of the change in pH.
See people setting up. And if you have a tank that has aqua soil, doing that not only gets expensive, but you're basically going through the maturation process that you have in the first couple of months. I do exactly what Michelle does. I'll pull out stuff, clean it out, and take a cup and a half and dump some aqua soil, and that just reinvigorates that section and also resets the buffering capacity for your tank. It's a whole lot cheaper to do it that way, and it gives you a lot more longevity in your aqua soil, so you don't pay 60, 70, 80, $90 for a bag of aqua soil now. That lasts you quite a while.
And there is, if you're maintaining your tank, and so I haven't actually reset this tank in 3 years, right? And it's, I've been a bit lazy. It doesn't look quite as good as this at the moment, but my air conditioner broke, right? This is an aside story. So I call in the air conditioner guy, and of course he's coming to my house, and he is like, sees this tank, and he's like, jaw on the floor. He's like, oh my gosh, this tank is incredible. How do you do that? I have a fish tank. It doesn't look anything like, so it doesn't look that bad, right? But so the point there is that you can have like a mature tank that is well maintained, but there are tricks like making sure you are getting that mulm out of the bottom, and that you are renewing your aqua soil, like using a handful here and there. And root tabs, and you wouldn't think you would need root tabs with aqua soil, but when you've got 3-year-old aqua soil and you're putting very low amounts of nitrate into your water column like I am, you need root tabs, and those can be a really good friend to you. And with root tabs,
and with equilibrium. Equilibrium is like a combination calcium magnesium additive that's what I strictly use at home for reconstituting.
All right, guys. Well, really great discussion. It was great to get up in front of you today. Thank you so much for your time, and I'll let us get to the raffles because there's a lot of exciting stuff here.
Okay, thank you guys for being, for you guys coming online. We're gonna go ahead and stop sharing at this point and hopefully see you guys at the next meeting.